Hello everyone, I'm Aumkaar here, and this is the first part of DIY assignment 4 where I've created simulation for open loop control of DC motor. So this control is based on PWM, and PWM stands for pulse width modulation. It indicates for how long a digital signal is in on state, and varying this active time period of a digital signal can create an analog result. So this analog result will further help in controlling the motor, actually the speed of the motor, and that speed in rotation per minute is equal to max speed multiplied by PWM by 255. So the max speed here I have taken is 250, and the maximum value of PWM that is allowed is 255. So when we give the command that analog write 255, then this will request a 100% duty cycle. I have started the code here by saving the value of PWM in the integer variable of the same name, and then pin 12 has been powered on. So the pin 12 here controls the direction of rotation, where 1 will give clockwise rotation and 0 will give anti-clockwise rotation. Since it is powered on right now, so when we will run the simulation, the motor will run in clockwise direction. Further, pin 8 has been set at low power because this will disable the brake, and we don't need brake in this current experiment. Now, enable pin at A is connected to pin 6 via pin 4. So this pin 6 on Arduino is where the PWM signal is generated. Using the analog write command, we will generate the PWM signal of this value on pin 6. Moving on to the simulation. Here I have edited some parameters of the motor. These two values have been changed, where coil inductance has been decreased from 100 millihenry, the default value of 100 millihenry, to 1 millihenry, and zero load RPM has been decreased from 1000 to 250. These two changes were done in order to decrease the time that is taken to reach the steady state. So we'll click OK and run the simulation. Here we can see that the motor is rotating in clockwise direction, and yes, and now the speed has settled at 106. Now we'll change some values in the source code in order to see how it affects the rotation of the motor. We will start by decreasing the value of PWM. We'll make it 120, which is half of the initial value, and then we will power off pin 12, set it as low, so that now the motor will run in anti-clockwise direction. Okay. This will compile the code. Okay. Now we'll move on to the simulation. Here again, we'll run it. And now you can see that the motor is running in anti-clockwise direction. And the value has settled as 63.7. So this was the first part of the assignment. Now we'll move on to the second part. The second part of the assignment is to visualize a control system virtually using Node-RED. So there are two control systems here. The first one is a water level controller, and the second one is a gas pressure controller. Each has a slider in it. In the first case, there is a gauge that displays the water level, and in the second case, there is a bar chart to display the gas pressure that we can set using the slider here. Here we can see that the slider can set the level of water from 0 to 100, and the step is of 1. Similarly, in the gas pressure slider, the minimum is 0 and the maximum is 40. Again, the step is 1. Now these two control systems can be visualized from here. Here you can see that first we have the gauge that tells us the water level, and then there is the bar chart that will tell the gas pressure. The slider of water level controller should have ideally been here, but somehow it has been placed here. I don't know why, but still it will work. So we'll set the water level 26, and we can see the gauge responding to the same. Again, we can move it further to 48. The color will also change as we change the value. Now if we go set it at 93, then it will become almost red. Yes. So that's the water level controller. And now we can see how the gas pressure controller works. We have first set it to 10, then 18, and then 25, and the maximum value is 40. So this is represented by the bar chart. So this was my assignment 4 for DIY lab. Hope you liked it. Thank you for watching.